In a physics lab, a cube slides down a frictionless inclination. An elastic light strikes another cube at the bottom that is only one half its mass. If the incline is 8 centimeters high and the table is 90 centimeters off the floor, where does each cube land? So we take that both leave the incline moving horizontally. So this one has got a mass m and this one has got half the mass, so that would be half m. And this one is sliding here and it comes to hit this other one. And so upon hitting this small mass which is at the bottom, they are going to drop and they'll first move horizontally and then they'll suddenly go on dropping. So one is going to drop a much further distance away and the other one is going to drop just a little distance. We can take it that the one which has a bigger mass drops on a very small distance from the beginning, because it's more like the force of gravity acts on it more because it has got a bigger mass in comparison to the small mass. So let's call this as the one which is m, and then this is going to be half m. Now I want to find their distances from the bottom of this building where they dropped. So let's call this as the first range, range 1, which we want to calculate where it drops from the beginning. And then the other one, you can call it second range, range 2. That is between these 2 points at bottom of the building there. Alright. Now firstly we need to understand with what velocity was this moving when it had to hit the second mass. And initially this one is on top there, so it is not moving initially on the top there, it only has potential energy. But as it begins to slide, when it reaches the very bottom here, all the potential energy has been converted into kinetic energy. And so using the conservation of energy, we are saying potential energy at the beginning is going to be equal to kinetic energy at the bottom. That is because we are taking this incline to be frictionless. So the energy conversion will just be between potential and kinetic. And the potential energy is mass times gravity times height. Kinetic energy is half mass velocity squared. So you can see masses cancelling out, and g we know that is 9.8. The height of the building here, or the height of the incline, is 30 centimeters, and we can convert that to meters just by dividing by 100, and that will give us 0.3. And then we have got half v squared. So we can multiply everything by 2 so that v squared remains alone. So that will give us v squared being equal to 2 multiplied by 9.8 multiplied by 0.3, and v squared is going to give us about 5.88. Taking the square root there, v is going to be 2.42487 meters per second. So this is the velocity at which it will be moving when it hits the second mass here. Now, from the conservation of momentum, this velocity with which it is moving, it is the initial velocity that it is going to strike this with. Now, if they hit each other, with what velocities are they going to be all traveling at? So this v we have found, we are going to call it u, the initial velocity with which it is going to hit the second mass. So from the conservation of momentum, m1 u1 plus m2 u2 should be equal to m1 v1 plus m2 v2. Now m1 is just m, u1, that is the initial velocity at which it was moving, that is the one we've calculated, 2.42487. m2, this mass was initially at rest, so that will be 0, and that is going to be equal to m1, which is simply m, and then v1 plus m2. M2, we know that it is just half of m, so we'll say half m, and then v2. So from here we can see we are going to get 2.42487m is equal to mv1 plus half mv2. The masses are common in everything, so they are going to cancel out, and we are going to remain with 2.42487 being equal to v1 plus half v2. And let's call this as our first equation, because we have got two unknowns in this equation, so we're going to keep it like that. Now, our problem has told us that the two masses are to hit each other elastically, meaning kinetic energy was conserved in elastic collision. So using the conservation of kinetic energy, initial velocity of the first mass plus final velocity of the first mass should be equal to initial velocity of the second mass plus final velocity of the second mass. The first mass was moving with a velocity initially of 2.42 and then 487. The final velocity of the first mass we don't know. The initial velocity of the second mass, it was initially at rest. We can see it isn't moving here, so it was at rest, so that is 0, and then plus v2, the final velocity at which it was moving. So from here we can just make v2 the subject of the formula. That will be v2, I've just started with this portion, is equal to 2.42487 plus v1. This will be our second equation. So now what we are going to do is we are going to solve the two equations simultaneously. In this second equation, where there is v2, I'm going to substitute this term. So that will be 2.42487 being equal to v1 plus half. Where there is v2, we are going to put 2.42487 plus v1. So this will give us 2.42487 being equal to v1 plus, so we are going to multiply half by this number, or just divide that number by 2, and that is going to give us 1.2124 plus, this is 0.5, which is just a half multiplied by v1. That will be half v1, or we can say 0.5 v1. And at this point, we're going to arrange the like terms. So I'm going to take this term the other side. So that is going to be 2.42487 minus 1.2124 being equal to v1 plus 0.5 v1. So subtracting 2.42487 minus 1.2124, we're going to get 1.2124, and this will be equal to v1 plus 0.5 v1. That will be 1.05 v1. So dividing by 1.05 both sides, v1 is going to give us, that is 0.80829896 meters per second. So that is the velocity at which the first mass m is going to be moving as it drops. That will be the v1. And then v2, that is the second mass, that is the velocity at which will be moving as it gets to drop. Now let's calculate what will be v2. We can use this formula here. We just substitute in the value for v1 that you found. And so V2 is going to become 2.42487 plus, where there is V1, we're going to substitute 0.808, that is 2896, and this value is going to give us 3.233 meters per second. So these are the velocities as to which they are moving as they get to drop. So V2 is equal to 3.23 meters per second, and then V1, this is going to be equal to 0.802 meters per second. Okay, now I can remove some this space. We want to find the range where they drop, and we know that as these masses were dropping, they were moving horizontally as they got to drop. In other words, these velocities which they have as they get to drop are just in the x component, they are not in the y component. Now, the first thing is, let's deal with this first one, V1, and let's deal with the mass 1. That is the mass which fell at this point. Well, because these two masses were dropping from the same point, we are going to take that they are going to hit the ground at the same time. And to find the time at which they are going to hit the ground, we are going to say height is given by initial velocity times time plus half gt squared. The height, they were both dropping the height of 90 centimeters, which is 0.9. Well, the initial velocity is 0. That is because these masses were moving horizontally. They didn't have any component in the y. That is the meaning, both leave the incline horizontally. They didn't have any component in the y. So the components which they had was just in the x. And so the initial velocity in the y is 0, because when we are talking about height, we use the component that is also in the y. And plus half, our g here is 9.8 t squared. So that is going to give us t squared being equal to, what I'll do is I'll multiply everything by 2 so that this 2 cancels also, and then divide by 9.8 so that this 9.8 cancels out. So that is going to give me 2 over 9.8, and this is going to multiply with this value which is here 0.9. For me to remain with t, I'm going to square root. So that will be the square root of 2 multiplied by 0.9 over 9.8. And t is going to give 0.42857 seconds. So this is the time that both of them took to fall for this kind of height which is here. Now what will be the distance of each? So let me just record the time here. The time is 0.42857 seconds. So for considering first mass 1, M1, which is the heavier mass, we know the time it took to fall for this kind of height, and we know the velocity with which it was moving as it got to fall. And we want to find the range, that is range 1 for mass 1. So range is given by velocity in the x multiplied by time. And we know that the velocity with which these masses had to fall is just the velocity in the x, because they were moving horizontal, they didn't have any component in the y. So for mass 1, that is 0.808. Okay, this was 8.082 which we calculated earlier. And then we're going to multiply this value. This is not the full number. The full one which I wrote earlier was 0.8082896. Now we're going to multiply with the time that they had to fall. The mass had to fall for that kind of height, and that is 0.42857 seconds. and the range is going to give us, if we do the multiplication, 0.346, which we can leave as 0.35 meters. Considering mass 2, also the range, that is range 2, is going to be given by Vxt. It was also moving horizontally as it moved out of the incline, and it was moving at a velocity of 3.23, and then we're going to multiply by the time of flight it took, the time it took to reach the bottom, that is the same time, that is 0.42857, and so this is going to give us 1.385 approximately. We can say that is to two significant figures, 1.4 meters per second. So this was all about this video. Thank you so much for watching. If it was helpful, please do subscribe and follow more about the videos.